Everybody, it's Tyler here at the Chicago Robotics Invitational, checking in team number 11329, I.C.E. Robotics, coming out of Bloomington, Indiana. This team, by the way, Indiana State finalists. They won the Indiana South Championship as well, too. So very excited to talk about this robot. And to help me here, I have Emerson, Brock, and Hazel. And we're going to be talking about, of course, following that ring journey through this robot run program there, into, of course, the wobble goal mechanism. Shooter, we'll actually see how this shooter works down on the floor, and some cool feedback all here coming up on Behind the Bot.
Giving you a voice.
Making it loud our own way.
Welcome to the fun.
We would like to thank our friends at Stryker for supporting fun so we can continue to make content for you. Stryker makes some of the most revolutionary medical equipment and is a big supporter of FIRST and its participants. If you are looking for an internship or a career that supports you being in FIRST, check out careers.stryker.com to learn more. Hey FTC fans, are you ready for Freight Frenzy? Join us after kickoff live all weekend, September 18th and 19th, as we'll be out at Kettering University for the Bulldogs Robot in 30 Hours at youtube.com/first updates now. You'll get detailed breakdowns of game elements, the field, and prototyping and testing of robot components and assemblies. Watch live, view short videos after, and ask questions for the Kettering team at youtube.com/first updates now.
So Emerson, start us out on this robot here, talking about the intake, kind of what went into it, some of the mechanisms and thought process behind it.
All right, so hello, we'll just get right into it. Our first initial design of this robot didn't actually have this drop-down intake. It was just this part right here. It has a floppy bit right here so that we have a little bit of play when we're intaking the rings. It also started with just PVC. Now we use surgical tubing. We got inspired by one of our teammates at the Indy South Championship to do this, and it's worked a lot better. Going into our fourth remote week, we added the drop-down intake because this has a narrow window for intaking the rings. So this widened that and allowed us to also grab the stack in auto. So Brock can go ahead and demonstrate the intaking.
And does this intake, does it stay down the whole match, or does it actually come back up?
Yeah, as soon as the match starts, it just flops down and stays down. So that feeds right into our magazine. It's a little bit difficult to see. We just use entraption stars from Andy Mark, and they continue to run while the rings are fed in, and since they're floppy, there's no issues there. This was actually inspired slightly from team from Australia that we looked at their reveal and thought that was
one of
really
the Barker
interesting.
teams?
Yeah, it was Barker
Gotcha.
Raybacks.
Gotcha. One of the things I asked on here that I saw was really neat is when the rings were coming in, a lot of teams have done this type of thing. They don't have a really a way to say, hey, like a new ring's coming in, therefore move in. So when you were thinking about doing this linear type shooter, where in the thought process was that where you're like, hey, we need to make sure that if we don't have 3 rings right away, there's still areas to space that out?
So like I said before, this kind of brings it in and then just keeps it running. So it magazine's just the 2, and then if there's 3, then we have LEDs up here that light up corresponding to the number of rings we have. So we have color sensors placed inside this magazine that count 1, 2, and 3, and then we know if we have the right amount of rings.
Gotcha. So Brock, anything else to add in regards to the feedback sensors, and let's talk about the wobble goal mechanism as well.
Yeah, so the color sensors that we have in the magazine, they're especially helpful this year because, as you can probably tell, the magazine is sort of hard to see, especially when it's on the field and 20 feet away from us. It's very hard to tell if we have 3 rings or if we've missed one, and we don't want to waste time shooting cycles of 2. So it's very helpful to see that this light turns green when we have 3 rings, and if we don't have 3 rings, it'll go blue for 2 or yellow for 1, and it's been a huge help for that this season overall, just being more efficient. Coming over to the wobble goal, this arm is made almost entirely out of wooden laser cut parts. It's been very, very effective for us so far. It has fingers that open. The robot's initiated right now. But it drops down to pick up the wobble goals off the floor, and it can store them in the robot while we're moving during the match. And we can drop them over the wall very quickly, and it's been very easy to run 2 cycles, 2 wobble goals at the end game.
One of the things I want to mention, I don't know who wants to talk about this as well, but I think we need to talk about your aesthetic a little bit with the laser cut wood on here. So talk to me a little bit more about some of the thought process behind that. For some people, it's just an aesthetic choice. Some people, it's like, hey, this is a material on hand. What made you go this route as well?
So we don't have available. We don't have access to a CNC or a router to do Lexan. That probably would be what we do if we had that. But Hazel, their family owns a laser cutter, as do we have access to one at a makerspace. It's in our city. And so it's really easy to get parts that way. We have a ton of spares, and it's light and cheap and really easy to prototype different things. So if you make one that doesn't work, it's not really so much of a loss as like Lexan or making it out of metal. So it's just really simple and works really well for FTC.
And it looks pretty sweet too, right? So nothing wrong with that. So let's wrap up this robot. We're going to put it on the ground and take a look at the shooter. So Hazel's going to tell us a little bit more about some of that process and some of the coding that goes into that as well.
Yeah, so our shooter is a basic design consisting of a one-to-one build a yellow jacket motor, a gear to act as a sort of flywheel in order to make sure we have enough power and we can hold a steady velocity. And then, of course, a standard, I think, Coulson wheel, which we use for actually interacting with the rings.
So let's see a couple of those fire off, and we can see a little bit how the accuracy works on that. It's a very quick succession for firing. One thing to ask on there, obviously with the additional weight of the flywheel, do you keep your shooter going the entire match, or do you let it spin back up? And if it does spin back up each time, how long does it take to do that?
So our shooter has, the way we work is we have 2 PID loops, so each is tuned independently. Since keeping it at a really steady speed is very power intensive throughout the match, we decided to create a relaxed PID loop, which throughout the match will just keep it within the general area, sort of oscillating around where it needs to be. So that way it uses the minimal amount of power required. But once we actually start shooting, it switches to an aggressive PID loop, which tries really hard to keep it at speed. So that way we can push out as many rings as we need to as fast as we can, while keeping good consistency.
Well, I.C.E. Robotics, thanks a lot for taking time to tell us about your robot. Looking for maybe a little bit of revenge here at CRI, as the 2 teams that you went down against at the Indiana State Championships are here, so can't wait to see how you do here at CRI, and of course featured competition as well. Thanks a lot for taking the time.
Thank you. Thank you.
We would like to thank our friends at Stryker for supporting this video. Stryker is looking for current and future FIRST alumni to join their internship program, and FIRST mentors who are looking for a great career with a company who actually supports their FIRST journey. Go to careers.stryker.com to learn more. You can also directly support Fun by joining Fun Nation. Click the join button, and just for a few bucks a month, you'll unlock special perks and directly support us so we can keep making great content. Don't forget to like, subscribe, and ring the bell to stay up to date on our new videos. Keep the conversation going and provide your input to our content. Watch our live shows at twitch.tv/firstupdatesnow. Join our Discord at discord.gg/firstupdatesnow. And check out Fun FTC on Facebook, Instagram, and Twitter, and First Updates Now on Facebook, Instagram, TikTok, and Twitter.